We're studying AP Physics B. This is section 1.5, Scalars and Vectors. It's an introduction to the differences between scalars and vectors, what a scalar is, what a vector is. Because we have to understand the difference between these two, between a scalar and a vector, before we study physics. It's one of those definition things. We all have to understand what the definition of some terms are before we can start talking about it. So we're going to look at that, and we're going to see that a scalar is a quantity that can be described with a single number, including any units, giving it size or magnitude. And units are just how we're measuring something. Like we're going to measure time in seconds, we're going to measure distance in meters, and so on. A quantity that deals with both magnitude and direction. You'll notice up in the scalar quantity, we didn't say anything about direction. Now direction comes into play when we're talking about vectors. So some examples of scalars would be volume and time. They do not have a direction. Now some people say, well, time moves forward, but in physics, that's not considered a direction. It's not a vector. It is a scalar. Some other common examples are, for temperature is 20 degrees Celsius, mass 85 kilograms. Neither one of these two have a direction. They have magnitude only, no direction. So that's what a scalar is. Vectors, on the other hand, have a direction. So for example, the car moved a distance of 2 kilometers in a direction of 30 degrees north of east. It has both a magnitude, which is the 2 kilometers right here, and it has our direction. So that's a vector. Now, because direction is an important characteristic of vectors, arrows are used to represent them. The longer your arrow is, the bigger your vector is. The direction of the arrow shows the direction of the vector. So here's an example of a block on an inclined plane. This gray triangle is our inclined plane. It's just a ramp, basically. And 3 vectors have been drawn to show the forces acting on this block. This block is sliding down this hill here, and there's 3 vectors that we're going to discuss in physics. Now, in future chapters, we're going to have to know this, but I'm just trying to give you an example of how we're going to use vectors. I don't expect you to know this now. I just want to give you examples of vectors. mg, mass times gravity, is the weight. It's straight down. The normal force is represented by a capital N. That's the surface pushing on the block. The force of friction is the frictional force between the block and the ramp, and that's trying to stop the block from sliding down the ramp. So that's why it's up the incline. So here's a vector diagram of a block sliding down an incline. Here's a more complicated vector diagram. We do not get into vector diagrams this complicated, but this is just one with a rocket shooting up. You can see all sorts of different things: the weight down, the thrust up, the drag is the air resistance, the lift. So here's just some more vectors showing that are used or applied to a situation. I have things that we're going to be using here are called applets, and we're going to look at an example of this animation, and it shows how vectors are used. Another example of how vectors are used. Now, what we have here is this black dot. If I hit start, you'll see this black dot move along that red line. So we have this called a projectile. It follows a path. It's like a ball being thrown off a roof or something like that. So I'll reset that. But I want to see what the velocity vectors do during that path. How does the velocity change? So I'll hit start again. You'll see those velocity vectors are always changing throughout the path. So we'll talk about velocity vectors in that sense. But if we talk about acceleration vectors, you'll notice that the acceleration vector stays the same the whole time. If we talk about the force vector, and I should have that go through, the force vector stays the same the whole time. But the velocity vectors are always changing. So this is a way, these vectors are a way of helping us study physics, understand exactly what's going on in a particular motion. And again, I'm just giving you examples of vectors. I don't expect you to fully appreciate what these vectors mean at this point. Eventually you will. So let's go to our last slide here. We're going to go ahead and look at our wrap-up. What have we learned so far today, or in this particular video? Vectors and scalars are tools we use in physics. Scalars are measurements with magnitude only. And vectors are quantities that have both magnitude and direction.